Hello and good afternoon to all audiences. We would like to thank everyone for joining us for today's podcast. So before we kickstart our podcast session, allow me to introduce myself. My name is Jimmy. I am currently the final year student from the Faculty of Engineering. Today we have our very special guest, which is also a lecturer from the Faculty of Engineering, which is Prof. Fabian here. All right, Prof, thank you so much for your time today.
Yeah, good to meet you again, Jimmy.
All right. So before we proceed further with the session, Prof, could you just give yourself a little bit of introduction about yourself?
Okay. Yeah, this is actually not my first job. My first job is actually I work as an engineer for Intel Microelectronic Penang. So I worked for 2 years as a designer for printed circuit board and also some simple analog circuitry. After 2 years I spent in Intel, I spent another 2 years with another company designing something what we call embedded systems.
Embedded systems, I see.
So at that company, actually I learned a lot of hardware design, especially designing things with a microprocessor, microcontroller, and also software development.
I see.
So after 4 years in the industry, then I decided to pursue my postgraduate, and that's how I ended up in MMU.
And be a lecturer since then.
Yeah, no, 2024 is my 25th years in the university.
Oh wow. Congratulations for that 25th years of anniversary works in MMU. All right, so your experience are mostly related to hardware, embedded systems. So could you just share us a little bit about embedded systems?
Perhaps before that, I just want to say that I actually dabble a bit here and there. And actually, I started out not as a robotics engineer or embedded. When I joined the university, I'm actually a microwave engineer.
Microwave
Yeah,
engineers.
this is something where I design those high frequency circuit that you are using in your telecommunication and wireless infrastructures. Things like microwave oscillators, amplifier, mixers, some bit of antenna, filters, and stuff like that.
I see.
Now, subsequently, when I did this, I also need to sometimes integrate all these modules and control it with software.
I see.
And that's how I realized that software is something very important. And slowly, I also branch out into low-level software development and embedded systems. Right. And what do you know about embedded systems?
For embedded system, from my understanding, is you need to use electronics components, and then you need to use softwares like Pythons or even Arduinos to actually provide commands. That's just my understanding.
Yeah, that's no, it's not a very accurate understanding actually. Now, there are two kinds of computers, like the one that you're using, your laptop or your desktop computer. That is what we call the typical standard computers. Then there is another kind of computer called embedded computer. So embedded system deal with embedded computer. And let me give you an example of what is called embedded computers. So the word embedded means the computer is included or inside your appliances. Unlike your laptop, you see that your computer is just a standalone. This is what we call a standalone computer. So it's just a computer. It's not connected to your appliances.
I see.
So embedded computer is the computer that is embedded inside your appliances. Example would be like your washing machine. There is a processor inside. Your air conditioning. There is a computer inside. That kind of computer is called embedded computer, or in engineering we call it embedded processor.
I see.
So other example will be could be your smartwatch, handphone, your appliances and the computer are merged. Calculator is also embedded. Televisions, and of course robotics, autonomous machines. The machines and the computer are integrated or embedded.
All right, thank you for your little bit sharing about your experiences. Just before we would jump on to the next question, I just would like to ask, right, in Faculty of Engineering, right, so what are the courses that are available in the Faculties of Engineering?
We actually have two branch of courses. One is actually Bachelor of Engineering. So that Bachelor of Engineering, there are a few majors, for example, electrical, electronics, telecommunications. And then there's another branch, it's called Bachelor of Science.
Bachelor of Science.
Bachelor of Science is more focused on I need to emphasize this Bachelor of Science is not an engineering degree. So that means it's not managed by board of engineers. So Bachelor of Science is more on
General.
it's actually a interdisciplinary program, and the focus is on robotics and artificial intelligence.
Artificial intelligence.
Yep.
So what are the courses that are available under the Bachelors of Engineering?
Now, offhand, I can't recall all the programs, but let me just state we have a Bachelor of Engineering majoring in electricals. So that is the traditional electrical engineering. We also have a Bachelor of Engineering, Bachelor of, I think
It's pure electronics.
Electronics. Then there is also Bachelor of Electronic majoring in telecommunications. And there is a Bachelor of Electronic majoring in computer. And if I'm not mistaken,
I think back then they used to have.
there is a Bachelor of Electronic majoring in nanotech.
I think that used to be back then.
Yeah,
But now it has been combined into electronics.
It's actually consolidated.
Consolidated. I see.
Due to change of the landscape of the engineering landscape and the market demand.
All right. So the titles that we are given today is robotics in an AI generations. So before we jump into robotics and AI, I think from your understanding, what is AI?
There are many definitions of artificial intelligence. Classical will be actually AI is an algorithm. It's an algorithm that can mimic a response of an intelligent agent. That means it can take input from, say, an environment, process, and can give an output. And this process can adapt to a change in the inputs, the change in the environment. Another way of AI is we can consider it as it's actually a part of machine learning. So machine learning is something like this. If you want to have a system where it takes input and then it produces an output, in a classical way is you need to write an algorithm and program it, list out the instruction. If you receive this input A, how do you process it to produce the output and so forth. In the case of machine learning, it actually we can say it developed the algorithm automatically. It do it by looking at a lot of samples. We call it the training samples. You show this is the output. With this output, we should get this. Sorry, this is the input that I put. With this input, we should get this kind of output. So we have a lot of this input and output samples that you feed into the machine. The machine, through an algorithm that uses something called optimization, it can can find out the best mapping or algorithm that link the input to output. So let me give you examples. If you a very simple example is machine vision, or we call computer vision. So face recognitions. If you're going to just look at, let's just take black and white grayscale image. So if you take a grayscale image, there is a human face inside. If you're going to make an algorithm that look at the pattern of the pixels, this image consists of pixels, that this lump of pixel represent or correlate with a human face, that is a very difficult process. You have thousands of pixels, and then how one pixel is related to the adjacent or the surrounding pixel, and what kind of pattern you need to look at, circular shape, black color, patch of black color, and some edges, and so to come up with a definition of what is a face. So, but if you have something called machine learning, it's part of AI, you can fit a lot of images, and then you say, this is a face, that is not a face, and so forth. Then the machine, based on this pattern, it can learn up the rules. So these rules actually embed into the hardware architecture of the algorithm itself. So there are two aspects of it.
So now we know a little bit more on AI. So based on your observation, right? So what are the current trends of robotics and AI in Malaysia?
Now, you mean industry that we
industry,
use, how
yeah.
we use robotic or how we carry out R&D in robotics.
I would like to specify more on the industry.
How the industry use robotics.
Yeah, industry, robotics and AI.
The classical usage would be like you see in the automobile industry, which we have been doing for quite a number of years, where this those classical robotic, just look at a robotic arm, it assemble your automobiles. Right. You see also in some heavy industries, not only automobiles, motorcycles, and other machine parts, where they use robots to assemble. This classical way of using robotics is the robot are actually not adaptive. That means you program a sequence and then you just follow the sequence. That is actually a legitimate usage. There is a newer usage of robotics there where human and machine can work together. And the kind of machine, the robots that you use in this environment is we call it a collaborative robots, or short for cobots.
Cobots.
So these are the classical that is used in heavy industry. That robot is very big, and then usually you need to cordon off an area. If you see in the automobile assembly plant, there is a section where the human operator cannot walk inside. So, but the cobot actually is designed to work together with human. You can work side by side. Maybe you assemble certain part that is too dexterity is too much for a machine, and then the machine can help with something that require many repetitions. So yeah, we are seeing that kind of trend.
Right. With that kind of current industry trend that are in Malaysia, so back to MMUs. So how do lecturers, help students to learn more about robots and AI?
Just now my answer is also there is another robotics usage that is very important today is those autonomous robot that move loads from one place to another. We call it autonomous guided vehicle, AGV. You will see that a lot in warehouses and those logistics companies and so forth. So these are the three main usage I would say on robotics. There's a fourth one which is service robotic, but it's not catching up yet.
It's not common in Malaysia yet.
I mean, you see this robotic arm make the coffee for you and things like that.
I think that's not really common in Malaysia yet. All right. So what are the opportunities, right? With all the robotics experience that you share with us, what are the opportunities where if students, and they step into MMU today, how can they expose to this experience in robotics and AI in our faculties?
I think I should increase the scope not to the faculty but actually to the MMU itself. So students who wish to pursue this area, robotics, AI, you can actually have two paths. One is you go for more software oriented. That means you go to computer science.
Computer science.
Yep. Yeah, so MMU will have faculty of is
computing and informatics,
and FIST
information science and technology. Yeah.
So that is pure software, and they are more focused on AI itself.
I see.
And then if you would like to dabble a bit in the hardware or maybe a lot in purely in hardware, then you go to faculty of engineering.
I see.
We also have our sister faculties, Faculty of Engineering and Technology in Malacca, that is pure robotics. So in Faculty of Engineering in Cyberjaya we have, I would say, 70% on robotics hardware and 30% on the software side. That include machine vision and artificial intelligence algorithms.
All right. So are there any current front projects that are that in our faculty right now?
You mean fun, FUN?
FUN, yeah, fun, or any robotics projects that you think they're interested and you would like to share with the audiences?
Now, there are indeed a few. But I need to, before I tell about the project, I need to stress that actually Malaysia is way behind a lot of other countries in terms of robotics. Like you see humanoid robot, and we are not able to build this kind of machine. Even the quadruped, quadruped means four-legged. Those like robot dogs and all this, we are not able to build it ourselves. So right now is we are trying just to play catch up to build this kind of machine. So we are building autonomous view vehicles, and there are also vehicles that's using two wheels, self-balance, but the upper body is a humanoid. That is easier than to make a full humanoid. And then also in the coming years, we are also going into four-legged quadrupeds robots.
I see. So I would like to ask, right? So, for students who are interested to join in our programs, in your opinion, what are the basic skills that the students need in order to shine in robotics and AI?
Preferably, we want students that in their high school already has this kind of hobbies, and then they already have doing like writing computer codes, maybe play with amateur electronics in their high school years. This kind of student will fare very well in the faculty. Of course, you can also have the, how to say, more classical one where they just finish high school and then maybe peer pressure or parents encouragement, and they just join, or maybe they see that this is a field to go into, and that now, but whatever it is, we need people who have you first and foremost. Your mathematics foundation has to be very strong. Example would be what kind of mathematics domain that you need: calculus,
Linear
algebra.
algebras.
Let's not talk about linear algebra because high school students may not understand what is
It's
that.
a bit too far for
We just say
linear
algebra.
Yeah.
Okay, algebra. Calculus will be like your integration, differentiations.
At maths,
Add maths, maybe just pure maths.
pure maths. Yep.
Okay, then things like how to handle this quadratic equation. Linear, of course, you need to handle linear equation, quadratic equation, and then the third order equation, we call it cubic equation, polynomials, stuff like that. It will be very useful. All right.
I see. So I got one more question for you. So, what do you think that robots will do in futures, and how can we as a students, to get ready for it?
Right now, I think the main, even you can see a lot of very sophisticated robots. Now, the main challenge in autonomous machine, I will just use the term autonomous machine, is how does the machine adapt to a real environment? Real environment is an environment that is chaotic. You have people moving around, furniture change, and so forth. That is the main challenge. A robot that can actually react effectively in a chaotic and or another way, a more technical term is unstructured environment.
Unstructured.
That is the main challenge in robotics. So yeah, we don't have a clear-cut solution, but robots are getting better and better to adapt to it. You can see, for example, there is a new, everybody will know about Boston Dynamics, they are human. But there are other companies like there's a robot called Figure One, humanoid, right? It's started to show ability that can adapt to unstructured environment. So in future, we have machine that can perform better in this kind of environment. And the second will be a machine that will have better and better dexterity. So action, like you see, if I can just reach out and twist my hand to take an object, looks very natural to say people or even to an animal, but to a roboticist to have a robot to execute this is still a lot of unsolved problems.
I see.
Okay, if you know this object, this shape, this of course it's quite straightforward, but when you don't know the orientation of the object, it could be random and so forth, then it is still a big challenge of a machine.
I see. So I think that's all about the basic, a bit of information about the robotics in an AI
Yes.
generation.
Sorry,
Yep.
Jimmy, there's something I need to add. Just now you asked about mathematics.
Oh yeah.
Something I need to add. In modern robotics, branch of mathematics that is very important is probability and statistics. That is something that is always overlooked. a lot of robotics today, we use a lot of statistics and probability. Modern robotic, we use something called probabilistic robotics. Example will be, this vacuum cleaner robot, right? You move
Yeah.
around in the environment. The modern version, they have something called localization ability. It based on the sensor detection of the object in the surrounding, it can guess where it is in your surrounding. And this guess is expressed in probabilities. What is the chances that I'm at location A and not location B and C? Based on this pattern of object signature that I detect.
Mm,
So a lot of algorithms are developed in this.
I see. So I think that wraps up our talks of robotics in and AI generation. So thank you everyone for watching. So if you have any comments or feedback, do feel free to drop at the comments below. Thank you, and we shall see you again.